Hey guys, here's the last lesson. This is for sure truly the last lesson. These are the ones you should be able to do, 7 to 14. And there's the answers for 7 to 14. I still have 2 more examples I'm going to go through. Then you should be able to get all of these ones done. There are definitely more equations on this page, but some of them are half angle, and we did none of the half angle formula stuff. And then some of them wrap back around to our original equations lesson, and I'll explain that when we get there. But let's take a look at the next 2 examples so that you see the big picture. So I made up this next example. It's right here. It looks like this. 2 sine 2x equals 1. Well, you can see there's a sine double angle thing, but you also see this 2 in the front, so guess what? I'm going to divide that guy out of there. And I'm going to say sine 2x equals 1/2. And remember, they want my answers to be between 0 and 2 pi. So I think, well, let's do this trick again. Let u equal 2x. Then the answers I'm going to look for are going to be double that. So I'm going to look between 0 and 4 pi. But I don't draw a sine graph, a squiggly sine graph to find this one. This says sine of u equals 1/2, and that's when I think, wait a minute, that's when I think reference triangles. So I'm going to be drawing a reference triangle. And if I do this and say, okay, this is my angle U, right? Terminal side, bang, boom, right? I could say opposite over hypotenuse. That would make this a rad 3. And I go, oh, that must be a pi 6th angle. That's what I have, is a pi 6th angle. Now, we also know that sine u equal 1/2 means there's another angle. Here, let me get this guy. Over here, there's this version of this angle. What is this red angle, this big boy here? Well, once again, you'd have your u prime. You'd have a reference angle. That reference angle would be a 1 over a 2, and that makes this a rad 3, be negative. But the sine of that angle would be a 5 pi 6ths. So I have those 2 answers. Those 2 answers are great for u. Not u, the letter u. But remember, u is from 0 to 4 pi. So guess what? I could go around this circle all the way around again and then stop here. Or I could go around this circle again and stop here. So what am I trying to get at? I'm trying to get at, there are 4 answers that I'm supposed to find here. My first answer, don't get me wrong, the first answer is pi over 6. The next answer that I got was 5 pi 6. Those are great answers. But if I rotate around one entire rotation, I'd be going around this 2 pi radians, and I'd add that pi 6. That would be the second, that would be the green colored angle that I drew. It would rotate all the way around 2 pi worth, and then I'd add a 6 to it. The blue angle would be if I went around again 2 pi, and I added 5 pi 6ths to it. So what is 2 pi plus pi over 6? Well, you can get common denominators or use your calculator and do 2 plus 1/6 if you want. That's 13 pi 6ths. Then 2 pi, well, that's 12 pi 6 plus 5. That'd be 17 pi 6ths if I add this stuff up. Now, wait a minute, I'm not done. because these four answers right here are for you. The letter U, not for you. Okay, I'm going to stop making that joke. I think it's kind of funny, but I won't. Anyway, remember, I know that U is the same thing as 2x, but I was supposed to solve this problem for x. So what am I going to do? I'm going to take this whole statement here. I'm going to multiply everything by a half. If I multiply it by a half, I'll get this to say x equals. Now multiplying by a half is pretty easy to do in your head. You'll get pi over 12. Not 5 pi 6, but 5 pi twelfths. Not 13 pi 6, but 13 pi twelfths. And then I think you can guess the last answer is going to be 17 pi twelfths. So you'll see that when you check your answers, let me scroll back up, check out some of this funky stuff. Hey, problem number 7 has twelfths in the answer. 8 has thirds in the answer. Look at this, 18ths in some of these. Now you'll also notice there's some degree answers here. Degrees are fine. You can work in radian or degree. But let me show you one here. I made up one more problem where I used degrees. So let's go down. I'm going to do one more example. And the example I'm going to do looks like this. I'm not going to get too fancy. I'm just going to go right to it. Okay. When you look at the problems in the book on page 273, if they give you x as your variable, the answer in the book is going to be in radians. But if they give you theta, then what they're going to ask you to do is work in degrees. You know where I'm going with this. I'm going to say let u equal to theta. And then that means u would be between 0 and double it, 720 degrees. So I'm going to rewrite my statement as the sine of u equals negative rad 3 over 2. And you see this. You see that that's 2 full revolutions around the coordinate system. So I'm going to end up with 4 answers again. And those 4 answers that I end up with are going to be with respect to u. So I'm going to have to take all 4 answers when I get to the end and multiply by 1/2. But in order to do this, it would be really helpful if I had a bow tie in front of me. But no, I'm going to have to draw this out. So here we go. I know that the sine of some angle u can equal negative 3 pi halves, not in quadrant 1 or 2. It would be in quadrant 3. So I'm going to draw this guy. Not drawn to scale, not perfect, but my first angle would have to be here, and that would give me a sine would be opposite over hypotenuse. That'd be a 1. So that makes this angle inside here a 60-degree angle, because they want me to work in degree mode this time. That would be a 60. But remember, I'm in quadrant 3, so it'd be 180 degrees plus that 60 degrees. So that angle that they want me to find would be 240 degrees. And I also know I could draw another angle. What the heck, I'll use different color here. I could draw another angle that would go all the way to here with a terminal side. Please, thank you. There we go. I don't know why I'm saying please to a iPad. Anyway, that angle would also end up with a little 60-degree reference angle inside of it. I could say that's opposite over hypotenuse, right? But that's not the angle they want. They don't say 60 in quadrant 4. They say, no, 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 that would have to be a 300-degree angle. But if I'm finding all these answers with respect to u, that means I could go all the way around this circle and then come back and stop right there. What would that be the equivalent of? That would be the equivalent of going 360 degrees of revolution plus the 240 degrees that I had from the other question. See that? And then I could add those together and say that answer must be the third angle they want me to find, and that would be a 600-degree angle. All I did is add those two together. Let's go get a blue pen, finish this baby off. If I did go 360 degrees of revolution and then come back around and stop right here, I know it looks messy, but that would be my terminal side then. That would be the same as 360 degrees plus my 300 degrees from the first set of answers, if you get my drift. And then I could add that together and say, oh, that's 660 degrees. There's my 4 answers. There's my 4 answers. But remember, all of these answers are with respect to u. I don't want them to be with respect to u. So if I multiply everything by a half, which is the same as divide it by 2, I would end up with my answers for theta. My answers for theta would be oh my gosh, hang on. Yeah, there it goes. 120 degrees, 150 degrees. Oh, dang it, don't do that to me again. Okay, I'm going to scroll away from whatever I hit. 300 degrees and 330 degrees. And if I look up in the back of the book, that would be the answers they would have because they used theta this time. So just be aware of this. On page 273, when you do the practice problems, if they use the variable x, your work will be in radians. If they use the variable theta, your work will be in degrees. On your final assessment, when I give you a problem, I'm not going to leave it to chance. I will tell you whether I want degrees or radians. Now, I have one more little thing to mention, and that brings us full circle, and it ties up this last section perfectly, and we're done. This is your last lesson, but it's on page 273. I'm just going to show you this guy. At the very bottom in this section, they have this problem. This problem right here is problem number 23, and this would not be a good candidate for what I just showed you. Remember, the other tricks that we already know are very good tricks, very valid, and they're very useful when this type of situation happens. You'll notice all of my examples from the previous lesson and this all have a single dude in them. A single dude in them. This guy has 2 chunks. So this is a candidate where we would not say let u equal 2x. This would be where we go, you know what? I could rewrite this to look like that. Then I could add it to this. I hope you see where I'm going with this. I could rearrange the order of things. And then I go, dang, that's a trinomial. I could factor. I could give it one of these. And then I'm back to the very first lesson I showed you about solving equations with trig functions. So, guys, this guy, because you have 2 pieces that you could not combine, you can't say cosine 2x plus cosine x is cosine 3x. It's not true. This is when you should put on the brakes and say this strategy doesn't work. This does not work. The strategy I just showed you is valid for things that only have one function in it, like that equal 1. You could do it this new style. This equal 1/2. You could do it this new style. But as soon as you see something like sine 2x minus 3 sine x, something like that, then you're going to have to use the double angle identity stuff for that. And you might say, oh, this thing could be rewritten as 2 sine x cosine x minus 3 sine x, And remember, I just made this guy up on the fly. And then I go, oh, GCF, so it's one of those factoring style problems, So that's the thing, guys. Not everything fits into this cool little category. Not everything fits into this category. But when it does, it's the trick to use. It's totally helpful. But don't forget, that's why we had 3 separate lessons on equations now. And all of this stuff is on your AP Calc Summer packet. So, it is, I've been waiting for a long time to say this. That's all there is. We get to hang it up. Congratulate yourself, pat yourself on the back. And then do page 273, 7 to 14 all. If you can do those, you're in good shape.